Hello everyone, welcome back. In today's demo, we're going to be looking a little bit in depth about how we practically use relationships in SQL databases. So we're going to start by looking directly in the SQLite 3 command line tool at how some of that stuff works directly, and then we're going to add subtasks using these features to the to-do list app that we were working on in the last demo. So first off, I'm going to open SQLite 3 in my terminal. I'm going to use this transient in-memory database as opposed to opening a file because I don't particularly care what happens to these tables after the demo. But if you'd like to save them, you can specify a database file. So let's start off just by creating a users table. We'll create table users. Sorry, I'm kind of slow at typing. I will probably be copying in a few things later in the demo. So we're going to, our users are going to have nothing but an ID as their primary key and a required, not null, name. So if we use the SQLite meta commands built in .tables, we can see that we now have a users table. Now, in order to actually save some information about our users, what we can do is create another table. Let's say we want to have user profiles, and we'd like to associate these profiles, one profile to one user, but for whatever reason we don't want them to be in the same table. Maybe our tables are getting kind of large and we don't always want the profile information. So what we can do is we can create a table profile, and this table will have its own ID, which is going to be an integer primary key. It will have status, which is just going to be some not null text representing the user's status. And then we're going to give it a user ID, which is going to be an integer that is also required. And so this user ID is going to reference the ID of a user we've created. So what we'll do is we'll say that we have a foreign key user ID, which references the users table field ID. So we can create that table. And then .tables again will show us that it's there. So what this basically means here, saying foreign key user ID references user parentheses ID. In most SQL implementations, what this should restrict user ID to be a value of an ID of a user. This actually is not the case in SQLite. SQLite kind of skimps on the requirements in a lot of areas, hence the light. So it will let you do a lot of funky things. But the way you should think of foreign key user ID references user ID is that user ID here must be an ID from the users table. So let's work that a little bit. Let's insert into users or user. I mean my table users. That's going to be slightly a problem. Because my profile isn't defined correctly. Let me just drop table profile very quickly and and make this correct. Yes. So what I'll do is I will insert into users. I want a name values, and let's just put in my name, Jack. And now we can select everything from users and see that I am the only entry in users. We can also select everything from profile and see that there's presently nothing there. So we can now insert into profile. We want to insert a status and a user ID, and we'll put in online and 1, my ID. We can now see that if we select everything from profile, we have one entry, where the entry being online and the user being 1, and 1, of course, is me. So we can insert a second user. We can insert into user's name values Rahi, my co-instructor, and then we can insert, actually, we can insert into profile. We're going to say away and 2. And now we can select from users to see that Jack and Rahi are both present, and select from profile to see that I am online and Rahi is away. Now, if we try to insert into profile, well, if we try to insert into profile now that Rahi is online, we will see that the unique constraint fails because Rahi already has a profile, and we will need to update it if we would like to change it. Now, ideally, we should also see that 3 fails if we try and insert something for value 3, because there is no user with ID 3. In other SQL implementations, that should fail. However, in SQLite, it does not, and we can get an unassociated profile. You should try to avoid doing that in general. So that was a one-to-one relationship, but that's not the only type of relationship we might want to model. Some relationships are what we call one-to-many. You have one object that references, or one entry that references a lot of other entries. So one way to think about that is, an example is albums and songs that are on an album. One album can have a lot of songs on it. So let's write that. So we can create a table album with an ID, which is an integer primary key, and a name text not null. That's there. And then we will also create table song. That didn't spell correctly at all. Create table song, which will have its own ID, integer primary key, name text not null, album ID, integer not null. And then, like last time, we're going to say that we have a foreign key, album ID references album ID. Now, it's worth noting, I think, that here, that album ID, unlike up here, where in profile we specified that the user ID was unique, we here have specified the album ID. We have not specified it to be unique because multiple songs can point in the songs table. We'll be able to point to the same album. So let's see that that's there, and now we can insert some. Let's insert an album and some songs. So we can insert into album name values. We're gonna say the Grease 2 original motion picture. The original motion picture soundtrack. And then we will insert into song. I'll just do a couple of the songs from this album. We'll say we want to put in a name, album ID, values, Cool Rider, great song. One, because this is our first album, and then we also want to insert, let's say, Prowlin, which is sung by Adrian Zmed, who plays Johnny Nogarelli in that 1982 masterpiece, Grease 2. So now we have those. So we can select. We can do some interesting things with this. For example, we can select count name from song where album ID equals 1, and find that there are 2 songs from Grease 2 in our database. We can also just select all fields and see that we have Cool Rider and Prowlin successfully in our database. So that's really fun. But there's one more important use case, I think, that hasn't been covered by what we've done so far, and that is a many-to-many relationship. When you have a lot of one thing, a lot of one type of thing, and a lot of another type of thing, and each one that might be each one of each type of thing might want to be related to a lot of the other type of thing. It's a lot of things related to a lot of things, kind of free form, no restrictions. So the way we'll do that is actually with another table. So let's take the example for perhaps of students in courses. I'm enrolled in X number of courses. Rahi's enrolled in Y number of courses. We are enrolled in some courses together. So in order to model that, we need a many-to-many relationship. So let's start with a student's table. The student will simply be an ID and a net ID. Very straightforward. We'll also have a courses table, which doesn't need to have too much either. It's going to be it's just going to be an ID and a title of the course. So we can see that those are in there now. And now in order to model the connections between them, we'll create an enrollment table. So we can see we've got our normal ID. Then we've also got a required student and a required course ID, each of which references an ID from the tables. So every entry in enrollment represents one connection between students and courses. So by not making the relationship directly a property of either students or courses, we're able to have as many as we want relating student IDs to course IDs. So now that we have all of those, let's let's do something. So we can insert into student. Let's put in a net ID values, and this hypothetical student's net ID will be ABC123. We will also insert a second student, DEF456. So then we can select everything from student and see that both of those students have been successfully put in. Now, let's also insert into course title values. Capitalization doesn't actually matter in SQL. It's more just a style thing. Oftentimes, when I want to go fast, I will just write everything lowercase. In my actual code, I try and make everything uppercase, but when I'm just messing around in the console, sometimes I just do all lowercase. It's mostly a style thing. You should stick to uppercase for your actual code that you're turning in to us. But for messing around, it really isn't important. So I'll create a course here, CS 1110, and then one more course, CS 1998, backend course. So now we can select star from course to see that those two are in there, and select star from select star from student. I can type, I swear. Select star from student. We have those. So now let's create some enrollment. So we can insert into enrollment student ID, course ID, values 1, So we'll say that ABC123 is enrolled in 1110. We'll also say that ABC123 is enrolled in CS 1998. Now, knowing those things, we'll also say that DEF 456 is enrolled in 1110. So now we can select star from enrollments. Enrollment, and see that A is enrolled in both 1 and 2, as well as ABC is enrolled in both 1 and 2, and DEF is enrolled only in 1. And this, could scale to an arbitrarily large number of students and courses. I think very, very logically. So this is a part of the demo where I show you something a little bit fancy that we don't really deal with directly in the course. So this is called a join, and I'll put it right in here and then explain it briefly. So what we do here is we are selecting from across multiple tables at the same time in one statement. So we are selecting course.title and student.netID. So we want the title of a course and the net ID of a student from. So what we're doing here is we're doing an inner join on courses, between enrollment and courses. So we're attaching the tables together everywhere that the enrollment course ID equals the ID of the course. And then we're joining again with students and combining that together anywhere that the student ID is the student. So what this gives us is one big table where all of the enrollment rows have been expanded with course and student information as appropriate. So if we run this, we will see that it has mapped our enrollment table to using our course and student tables to get that that ABC123 is in CS 1110 and 1998, and DEF 456 is in 1110. This is, in my opinion, very cool, and it's a little taste of the power that SQL can give you. So I just realized that I have messed up. I forgot to zoom in my terminal font. It may have been very small for you guys. I think it should still be legible, but I don't think I'm going to have time to re-record it larger. I'm very sorry. I will make the full text of what I typed and the output in the terminal available on Slack, and I will probably link it in the description of this video as well. I'm really sorry about that. I've zoomed my VS Code appropriately for this next part. So we're going to take the to-do list app from last time, last demo, and we're going to add subtasks to it. We're going to say that each task can have some number of subtasks that behave similarly. And so that's going to involve us using some relationships in our database. So let's start there. So first off, just for my own sanity, I want to add a little helper function. Two little helper functions, actually. So the first one is going to be called parse row, and it's going to take a row and columns. And what this is going to be is it's going to be columns is going to be the names in order of all of the columns in each table. So I'll just say parse row parse row equals an empty dictionary for I in range len columns. We're going to say that parse row columns I, so each name is equal to the value of the row at that index. And then we'll just return parse row. And then we'll do a second fun thing here, which is we will say we'll create parse cursor, and that'll take a cursor columns, and we will return a list comprehension. We will return parse row row columns for row in cursor. Cursor. There we go. So this is just to make everything a little bit nicer, reduce code duplication. What we can basically say here now is we can go down to, for example, get all tasks, and we can replace this entire little for loop thing with parse cursor cursor, and then we'll just give it the column names in order, which is ID description, ID description, done. And this will function the same as the code we just replaced, which just makes our life much, much more convenient. Now, I'm not going to go through and replace this everywhere. Down here, for example, we can, I guess I'll replace it in another couple of places. Down here, we can replace this with parse row, ID description, done. But mostly going forward, this is going to make our lives much more convenient. So we have all of these functions already that do a lot of fun things with with tasks. So now we want to add subtasks. So that's going to require a couple extra functions. So first of all, we're going to need a table. So we're going to need to def create subtask table self. So here we're going to try self.on.execute so we are going to create table subtask, which is going to have an ID, integer, primary key, description, text, not null, task ID in wait, it's done yeah, we're gonna have done boolean not null, and done should be lowercase. Then we're gonna have task ID integer not null, and of course, as you probably predicted, foreign key task ID references task ID. Great. So this is going to create us a nice little table. We'll have an ID, description, and done for each subtask, just like for our tasks, and then we will reference the ID of the task. So then we will accept exception as E, and just print E. So the other thing we're going to do is we're going to call this up in our constructor. We would not only like to create our task table, but we would like to create our subtask table as well. So we want to do a few things. We want to be able to do a few things with this table. We want to primarily be able to retrieve all of our subtasks, be able to create a new subtask, be able to retrieve a subtask by its ID, and of course, we want to be able to get all of the subtasks of a task. So let's write those real quick. Let's write, we'll first write get all subtasks self. So we'll say cursor equals self dot on dot cursor. This should be largely the same. Oh, sorry, yeah. We're going to do self.cron.execute. Select all from subtask. So this should really be largely the same as the things that you did last week in demo for the first few of these. So we're gonna parse the cursor, and our names here are ID, description, done, and task ID. And then we can simply return subtasks. We can write, we want to be able to insert a subtask. Insert subtask. And so that, of course, will require a description, whether or not it's done, and an ID for the task. So there, we'll say cursor equals self.con.cursor. We'll say cursor.execute. Insert into subtask. Description done task ID. Values question mark. And our values, of course, will be a 3-tuple of those 3 things: description, done, and ID. We will then, sorry, that doesn't quite fit. So we will then self.con.commit, and earn cursor dot last row ID just for our own use if we want it. We can also get a subtask by ID. This again should look very familiar. The self ID, this time ID is the ID of a specific subtask. We'll say cursor equals self.con.execute, select everything from subtask where ID equals question mark, and we will simply have ID in a 1-tuple. We'll then say for row in cursor, return parse row, and of course our column names are ID, description, oops, I keep doing that. ID, description, done, and task ID. Of course, if there is no row in the cursor, we will simply return none to signify that we haven't found anything. Now, the only one that's slightly more complicated than what we've already done is we want to get subtasks of a task that already exists. So here we're going to take self ID, but here the ID is the ID of a task that we would like to get all of the subtasks of. So our cursor is going to be self.con.execute select from subtask where task ID equals question mark. Oh, and I forgot up here to put a semicolon. Semicolon's very important. And we'll put an ID. So pretty simple, but this is the only real new thing. We're just, putting our things together, putting our tables together like this. Not even doing any fancy joins at the moment. So it's a pretty straightforward process. So anyway, our subtasks are going to equal parse cursor, and we're used to at this point ID, description, done, and task ID. And then we'll return subtask. So, hey, I made it through that without accidentally typing a comma inside of the parentheses. Pretty good. So with these in mind, we should be able to implement some fun new endpoints in our app. So how are we actually going to work with subtasks? Let's head over to app.py and add some more roots right above our launch code, but below the late task. So what we're going to implement today in terms of subtask functionalities, we're going to be able to create a subtask. We're going to be able to get all of our subtasks, and we are going to be able to get all of the subtasks of a specific task. We're leaving functionality like deleting subtasks or updating subtasks as like as an exercise for you guys if you're interested. But it's all pretty similar to the tasks functionality, and honestly, what's happening here in app.py is mostly just wiring those functions up. So what we're gonna do is let's add a root to create a subtask. So we're gonna app.root slash tasks slash, and then we're gonna have an int task ID slash subtask slash, and then so this we're going to, if we post to this endpoint, then we are going to call def create subtask. And that of course will receive the task ID from the URL. So we'll start, of course, by parsing the body with json.loads, request.data. You've seen this before. Our description will be body.get description. Then we will get our task. We'll say task equals db dot get task by ID, pass in task ID. And if task is none, we will return a failure response saying task not found. Otherwise, we will say that the subtask ID is equal to db dot insert subtask. We will put in the description we will default it to false, and we will use the task ID provided, which we've now verified is of a real task. Now we can retrieve our subtask using the ID we just got, db dot get subtask by ID subtask. And so we will then check if subtask is none, then we will return a failure response saying subtask could not be created for whatever reason that may have been. Otherwise, we'll return a success response passing in subtask as the data that we would like to return, so that our users can immediately see what they've inserted. So now I will test these all at once at the end, I think, just in the, I don't want to switch my OBS back and forth between the windows too many times. So we can also implement some other simple routes. For example, maybe we want to get all of the subtasks of a task, so we can copy this same route here. Just say that we're gonna remove the post, so this defaults to get, and this becomes very simple to write because we've basically already written it. So we'll take our task ID and we'll simply return a success response db dot get subtasks of task ID. If we wanted to, we could do a little more validation to give a little more informative error. We could do the same thing we did up here. So now if there's so yeah, we could take all this and say that, you know, if there's no such task, then we'll actually fail. Otherwise, we can just return the subtasks. And even if there are no subtasks, this method will just give us an empty array, which feels like the correct behavior. And of course, if we want to get all of our subtasks, we can just app.root /subtasks. This will be a get as well, a get request. And so if we get subtasks, and this will simply return a success response of db.get all subtasks. Fantastic. So let's see how this works. So I've got the server running. Let's test. We can test that currently we have no tasks in our database. We can create a task. I want to edit the third demo. Now, going back here, we can see that we have one task, ID 1, edit third demo. Yeah, we can also get that individually. See that I would like to edit the third demo. We can check its subtasks. So for task 1, we can see that there are currently no subtasks. However, we can create a subtask. So we'll go here. We will create a nice JSON object here. And this subtask will have the description open shortcut, which is the editing program that I use. We can send that task not found. Yes, I accidentally had this set to 0. So if I set it to task 1, which is the task, then we'll have big problems. So what happened there was earlier, and you may have caught this, I had accidentally written subtask here instead of subtask ID, when the ID of the subtask we want to get is subtask ID. So back to testing, I have to start over since I restarted. Oh wait, I don't have to start over because data persists. We can see that despite the fact that I've restarted the server, my task is still there, and I can now successfully... I didn't save my file. Now that I've saved my file, I can successfully add Open Shortcut, my editor, as a subtask. We can now check that the subtasks, there is... Oh, yes, and because of how I did that, I've accidentally now inserted 3, one for each attempt. But we can now see that I have to open Shortcut several times as subtasks. I could add a different shot. I could, when I'm done, I'm going to want to close Shortcut. So I can add that task. We can see now that close Shortcut has added 1 time to the list of subtasks for edit this demo. And we can retrieve all of our subtasks, which of course, since there's only one task, is just the 4 that we have somewhat accidentally created. So that's it for this demo. I hope that everything was comprehensible and I wasn't moving too fast. Sorry about the small text during the SQLite part. I will be making sure to attach the full log of that text so that you can view it alongside. I hope that's not too big of an inconvenience. Anyway, have fun with your assignments this week. Please show up to office hours, ask me questions, reach out on Slack. I'm happy to talk about almost anything programming and many things that aren't. Anyway, have a great week.